Hey everybody, this is Games Plus James, and today we're going to take a look at creating some space flight movement in Unity. We're going to create this simple system where we can look around and move as we go and basically fly around in all directions in space. And this is something that I used in a recent Game Jam game, which was a lot of fun to work on, and it feels quite fun to fly around controlling. So let's go ahead and dive in and see how this works. Okay, so we have a very basic project set up here. If you want to follow along with the exact same project files that we have going on here, you can do so by getting them in the link in the description down below. All that we've got included is this little ship to represent the player, but equally you could just use a cube for practicing this on, which has a few trails and stuff behind it. We've got a camera and our light by default, and we've got this asteroid field, which just takes this one asteroid that I have, and if I press play here, it just fills out the world with a whole bunch of copies of those asteroids. It's very simple. That's all that we have going on. None of that matters. That's just to give us some context to see when we're flying around, to make things look a little bit easier and to be able to tell that we're actually moving. But with that on mind, we have these basic things set up. But what we want to deal with is actually making our player move around in the world. So what we're going to do is, I'm going to stop this and I'm going to go and create a new script. Create a C# script that I'm going to call the ship controller, and then I'm going to attach that to my player ship here, pop that on there like that, and we're going to open this up in Visual Studio. So what we're going to deal with first is moving our ship around along the three normal axes that you'll have. So you'll have forward and back movement, left to right movement, and up and down movement. So we want to set all of those up, and they're very, very simple to do. They're probably the easiest thing of what we're going to do here. So let's create a few variables to allow us to control that. So I'm going to go up here and I'm going to create a public float that we're going to call forward speed, and that's going to be how fast we want to move forward. We're going to have strafe speed, which is how fast we want to move sideways, and then we'll have hover speed, which will be how fast we want our player to move up and down. So I'm going to give these all some default values. So let's say our forward speed will be 25, our strafe speed will obviously be much slower, so that to be, let's say, 7.5, and we're going to set our hover speed to be 5 by default. Now obviously you can play around with those numbers in the editor and all that. It's just nice to have something to base our inputs on. We're also going to add a private float for each of these that we're going to call active forward speed, active strafe speed, and active hover speed. And these are basically what's going to store the input that we have. So when we're pressing forward, we're going to use this as 25. When we're pressing backwards, we'll do this as minus 25, for example. So those are our first bits of basics. Let's go ahead and make them work. So in our update here, we're going to go down to here. We're going to say our active forward speed should be equal to whatever our input dot get axis raw on the vertical axis. So on the, when you press up and down arrows basically, are W and S on the keyboard. And we're going to multiply that by our forward speed. So we're going to do the same for the other directions too. So for our strafe speed, which is our side to side, that will be our active strafe speed is equal to input dot get axis raw horizontal. And we're going to multiply this by our strafe speed. There we go. And then finally, we're going to have our hover speed. So this will be our active hover speed should be equal to, well, we don't have any more axes available. So in Unity by default, we have a vertical and a horizontal axis set up by default, and that allows us to control our forward movement and our side to side movement. But if we want to move up and down in space, we could, well, first of all, we could just take some input from two particular keys if we wanted to, so we could write all that out, or we could go back into Unity and add an extra input axis. So let's do that. There's a much more simple way to do it. So we'll jump back into Unity. I'm going to go to Edit, Project Settings, and in the Input Manager here, I'm going to get the vertical axis that I have already set up. I'm going to right click and I'm going to duplicate the array element. So now we get another vertical right here. And I'm going to rename this to be hover. And I'm going to change the negative and positive. So positive for when we're moving upwards, we'll make that the space button. And when we're moving downwards, we're going to use left control for the standard and simple setup. I'm going to remove S and W from also working because we don't want those to work too. And if you want to set up for a controller, you could also add same as the vertical down here, but you'll have to add some different buttons and stuff like that. But we're not going to worry about that. We're just worrying about the keyboard for the purposes of this tutorial. So I'm going to close out of that. Now we have a hover axis that we can use. So let's go in here and we're going to say input.getAxis raw. And this time we're going to use the hover axis that we just created. And we're going to multiply this by our hover speed. Okay, so we're getting the input now, which is great, but we're not actually applying this to our ship. So what we're going to do is make this obviously apply to our movement. And very simply, all we have to do for that is just say our transform dot position, whatever we currently have, we're just going to add on some different values. So for moving forward, we're going to say add to that the transform dot forward. So transform dot forward will be whatever direction the ship is facing. And the reason we do this is because obviously we're going to rotate the ship around as we move through space. So we always want to move based on whichever direction the ship is currently facing. So transform dot forward will always go forward based on the rotation of the ship. So we're going to multiply that by our active forward speed. And we're also going to multiply that by time.delta time. So now that we have all those inputs and we have this bit of it working, let's see how this works back in our game. So we'll jump back in here, we'll let that compile. And when I press play, I can now move my ship back and forward. So perfect, that works, but obviously our side-to-side movement isn't working and our hover movement isn't working. So let's go back in. We need to add on the same things again. So what I could do is make this all inline, but just to make it clear what's going on a little bit more, we're just going to go here and say after we've added on the forward movement, we're also going to add on the sideways movement. So we'll say here transform dot position plus equals transform dot right multiplied by our active strafe speed multiplied by time.delta time. And then finally, transform dot position plus equals. Actually, no, just to demonstrate how you can do this all in line as well, just so we're clear of how this stuff would work. We'll add it on here also, but because we're adding an extra bit of thing that should be multiplied by its speed and delta time, we're going to wrap this up in a bracket, and then inside another pair of brackets, we're going to say transform dot up multiplied by active hover speed, again multiplied by time.delta time. So this is just to demonstrate we can do this all on one line, or you could separate it out into 3 separate things to make it a little bit more easy to see what's going on. So let's just save this back into our script, back into Unity, and we'll let this play. And now there we go. We can move forward and backwards. We can move side to side a little bit more slowly, and we can move up and down. Okay, so perfect. That's great. We have our ship moving around. Obviously, we don't want our ship moving away from the camera the whole time. So just to make things easy, I'm going to go to my camera, and I'm going to make that a child of the ship here. So now when I play, we move around with the ship. So that's perfect. But our ship feels like it's moving very rapidly all of a sudden. So when we start changing a different direction, it kind of feels like it's snapping around, which doesn't feel great. So we're going to add some acceleration to how this works. So let's go back into our script. We're going to be able to control how fast our ship accelerates in different ways. So we're going to add a few more floats in here. So we're going to add a private float, and we're going to have a forward acceleration. There we go. And I'm going to set that to be 2.5 by default. I'm going to have a strafe acceleration. So this will be basically how fast we go from 0 to 1, essentially. So when I say strafe acceleration is equal to 2, that means it's going to take half a second to accelerate. So going from 0 to 1 would be 1 divided by 2. So we have our strafe acceleration, and then finally we'll have our hover acceleration, And I'm going to set that to be 2 as well. Okay, so what we're going to do then is here, when we're setting the active forward speed, instead of just directly setting it, what we're going to do is right in front of that, we're going to say matf.lerp. And we're going to lerp from whatever the current active forward speed is. Oops, that should be active forward speed to whatever the input is, and how fast we want it to happen is our forward acceleration times time.delta time. So that's how fast we want our character to accelerate, or our ship, sorry, to accelerate. So let's do the same thing for these other two. I'm just going to, rather than making you sit through it, I'm just going to flash forward to it being done. Okay, so I've added all of this stuff in here. So as I said, this is the same thing, basically repeated, but using the different variables. So strafe speed, strafe acceleration, hover speed, hover acceleration. I'll leave it up there for a couple of seconds if you want to pause and copy the same bit of code. But otherwise, let's save this and we'll go back into Unity. And now we should see when we change our directions, when we use our trail, there we go. We have much smoother movement of our ship. Okay, so with that done then, let's go ahead and make it so that we can make our ship turn around as we go. So at the moment, all we can do, again, if I just play it here, is just move around in this world. We can go up and down all we want to, but we can't ever turn around and see what's behind us, which isn't great. So we're going to add that in our script. So let's jump back into our script. And actually, just before we jump back into the script, let me just talk about what we're going to do here. So essentially what we're going to do is make it so that if the mouse is in the center of the screen, the ship won't move. But as we move to any edge of the screen, the ship will rotate in that direction. So when we look up, the ship will rotate to look upwards. When we rotate sideways, look sideways, the ship will rotate sideways, and so on. So it's basically just a very simple way to handle this movement thing, but it works really well and actually feels really good when you play around with it too. So obviously to do that, we're going to need a couple of things. So let's go up the top here. We're going to need a public float for our look rotate speed. So that's going to be how fast we rotate around. Let's set that to be 90 by default. We could pump that up probably a little bit, but 90 will be okay for now. And then we're going to need a way to store the position of the mouse in our game. So we're going to say private, sorry, not public. I'm going to say private here, private vector2 that we're going to call look input. So that's going to be how we determine where our mouse is on the screen. That's going to be a look input variable. And then we're going to need to know how far our mouse is away from the center of the screen. So we'll store in the look input where the mouse exactly is right now. Then we'll need to calculate how far it is away from the center, because we need to know how far we should move and rotate. So we obviously then need to know where is the center of the screen. So we're going to store the center of the screen in a variable here. So screen center. And we'll have a final variable for mouse distance, which will store how far the mouse is away at any particular time. So in our start function, what we're going to do is say that our screen center, so we want to get the center of the screen, is going to be the screen center dot x equals screen dot width. So screen dot width obviously gets you the width of the screen that the game is taking up. So if your game is taking up your whole screen, it'll get the distance across the screen, which will be, say if you're doing a standard 1920 by 1080 resolution, that'll be 1920 across the screen. So we're going to go to the center of that for our screen center. So we'll just say screen.width multiplied by 0.5, and we'll do the same for the verticals. So screen center dot y is equal to screen dot height multiplied by 0.5f. Okay, so now we know where the center of our screen is, so that's perfect. We then need to, in our update, always be recording where the mouse is so that we can know where to look to. So we need to set our look input variable that we created up here. So our look input dot x will be equal to input dot mouse position dot x. So that'll just get us where the mouse is on the screen. And then look input dot y will obviously be input dot mouse position dot y. So that'll tell us where exactly our mouse is on the screen. Now the reason I'm doing this up here, just so I can point out as well, is we know we want to rotate the ship around and move based on the ship's rotation. So we'll do all the rotation stuff up here before we actually do any movement down here. That's why we're doing this up here rather than continuing on down lower in the script. Okay, so with that then, we then need to work out, or sorry, with that done, we then need to work out the mouse distance, which is how far we are from the center of the screen. And so our mouse distance dot x is going to be equal to wherever our look input dot x is minus our screen center dot x. So our current look input divided by, or sorry, minus the screen center dot x, and then I'm going to divide this by the y height, the y value of the screen center here, which is half the height of the screen. And the reason we'll do that is because essentially what we're saying is on the x-axis we want to make our ship here move to the right, say for example. Actually, no, I'm not going to explain this. I'm going to show it when we get to the point where this matters. So I won't divide it by this value just yet. Instead, what I'll do is I'll divide it by the x-axis value. So I'm going to say screen center dot x, and the reason we'll just do x for now is basically we want to say, hey, divide it by the half the width of the screen so we can get a number value. So say our screen is 600 across, our center is at 300, say we're at 600 here, then we want to say, hey, when we're at the center, 300 to 600, so 600 divided by 300 will obviously be 2. So we'll know that, hey, if it's 2, we're all the way on the right. If we're 1, we're all the way to the left here. Just as a simple way to do it. But with that knowledge in mind, then what we can do is say, when we divide it by the x value, we're whittling it down so it's a value. Well, actually it'll be between -1 and 1, not 0 and 2, because of the way we're subtracting things here. But you can always test that out by just debug logging these various different elements and seeing what happens. So mouse distance dot y is equal to, same again, so look input dot y minus screen center dot y, and divide this by screen center dot y. Okay, and that will give us as our mouse distance. And we're going to do one more thing to clamp this in a moment as well, but we'll return to that and see why we'll do that in just a moment. But what we're then going to do is, now that we have our mouse distance worked out, we can use that to rotate our ship. So we can go down here and just say, to apply that rotation, we're going to get our transform, and we're going to say transform dot rotate. Oh, not rotation, sorry, transform dot rotate. The rotate function is what we're going to use here. And the rotate function takes in some different values that we want to use. We want to give it an x, y, and a z axis rotation. And then we want to tell it what world space we're using. We'll get to that in a moment though. So let's say on the x axis, we want to rotate using our y mouse distance. So we're actually going to use y minus mouse distance dot y. We're going to multiply that by the look rotate speed that we created up here. And then we're going to multiply that by time.delta time, just to keep things smooth between each frame. And then we'll have for on the y rotation axis is where we use our mouse distance.x. Again, multiplied by look rotate speed and multiplied by time.delta time. And then for the moment on the z axis, we're not going to do any rotations. And then finally we have, you can see it says here space relative to, and what we're going to use is space dot, this tooltip will go out of the way, we can see it a bit better, space dot, we have self and world. So are we rotating relative to the whole world, or are we just rotating relative to the actual object of the ship? Well, obviously we're just rotating the ship around based on whichever direction it's facing, so we always want to use space dot self. So let's hit the semicolon there, save this. Let's go back into Unity and see this in action. And we'll see a couple of problems with this, but we'll deal with them in a moment. Let's maximize this when we play. So now you can see when I rotate, it does work nicely. But one of the issues is if I go up to there, you can see the speed I'm going when I rotate that way. But if I rotate this way, if I go further to the edge of the screen here, I can actually rotate sideways more than I can vertically, and that's because the ship is, there's more space to the side essentially. And also, if I unmaximize this and resume here, if I move my mouse off the screen, you can see I'm going way faster. I'm spinning like a crazy thing. We really don't want that to happen. We want to set a limit to how much we turn. And we also want to be able to only turn the same speed to the right as we can vertically. So, sorry, same speed horizontally as we can vertically. We also obviously want to be able to turn to the left the same way. So what we do is, instead of dividing by the x value here on the mouse distance.x, we divide it by y. So we're always using the smaller value. So again, imagine this is 250 up, and this one is 300 to the right, say. When we get to here, that'll be our 250. So no matter how much we move to the mouse to the side here, that won't matter. And the reason it won't matter is because if it's greater than 250, it'll be, say, 1.2 or whatever. We're going to make sure that this value can only ever be within a certain range. And how we can do that is just by simply saying mouse distance equals vector2 dot clamp magnitude. And what we're going to clamp is our current mouse distance, and we're going to say it can only be 1 in length. So what this does is, it'll never, no matter how much we move our mouse, if this value would be more than 1, we'll never be able to move beyond it. So if I save this now and go back in here and let this compile, and if I press play, now when we rotate, if I look up, that's perfectly fine. And if I get over to here and look to the right, you can see my rotation stays at the same speed. And even if I move my mouse way up here, we always have a consistent amount of rotation going on. So perfect, we almost have this system now working. We can turn in all directions as we're going. But one final thing it would be nice to be able to rotate our ship around along the forward axis. So basically be able to do spins, so we can orientate ourselves in different ways in the world. So we're going to do that very, very simply by going back in here. And we're going to add another value up here. We're going to have a private float roll input, which is obviously going to record how much we are rolling our ship. Then we're going to have a public float roll speed, which I'm going to set to be 90 by default, and we'll do a roll acceleration as well. So we'll do the same as we have for our forward and sideways motions. So roll acceleration will be, I'll set this to 3.5 by default because we want that to speed up pretty fast. And then what we're going to do is down here where we get all our mouse input and then we apply the rotation. Before we apply that rotation, we're also going to get the roll input. So we'll say roll input equals, we want to have another axis for this. So we want to be able to roll to the left and to the right. So let's go back in here and we'll add another to our input manager here. We have hover. Let's duplicate this. And this one is going to be roll, and negative is going to be Q and positive is going to be E. So on my keyboard, Q and E are obviously beside the W key, which is the kind of standard, WASD is the standard movement stuff. So we're using Q and E, which is either side of that. So we're going to say roll input here is equal to whatever that input is. So input, sorry, not, what am I doing? We need to handle our acceleration as well. So we're going to say matf.lerp from whatever our roll input currently is towards input.getAxis raw roll, so our roll amount, and then how fast we want it to happen is our roll acceleration multiplied by time.delta time. Okay, and with that done, we have our roll input being processed at this point. So instead of here when we're rotating, instead of 0 on the z-axis, in here we're going to say use our roll input, multiply it by our roll speed, and obviously also multiply it by time.delta time. and we can save. We can go back into Unity now, let that compile, and now when I press play, we should be able to roll our ship around. I actually just realized that this is going the opposite direction to the way I want to, so let me just go back in here, go to my project settings. I have these the wrong way around, so it just should be E for negative and Q for positive. And there we go. We'll roll to the right this way, and we'll roll to the left this way. And we now have full movement in our game. So we can now essentially move around to anywhere in our little world, and we're able to fully explore the world space that we've created. Now, one thing you might want to do as well is make sure that the mouse, which you can see for me is happening, is I can move my mouse off screen. So if you're shooting in your game or anything like that and you start clicking, and if you click off your screen when you're moving around, that's not going to be great. So I'm just going to very quickly throw in the start function here, a cursor.lock state equals cursor lock mode dot confined, which will keep our mouse in the center of the screen. Well, not in the center of the screen, just on our screen. So when I play, now I can't move the mouse outside the area of this window unless I hit the escape key. So perfect, there we go. That's our full spaceship flight controls working in our game, and it's a lot of fun to just fly around. I know when I first created this, I spent ages just kind of flying around with this ship, not really doing anything, just kind of having fun. It would actually be a lot of fun to just make like a space exploration game, I feel like, just using these kind of controls. But there you go. Thanks for watching this video. I will be back soon with more tutorial goodness in the very near future. If you haven't already, make sure you go and wishlist our games Scoot Kaboom and the Tomb of Doom, which you can find a link to in the description down below. Really helps us out. And of course, hit that subscribe button, hit the likes, do all the cool stuff. Let us know how you're getting on. And if you make a cool game using something like this, definitely make sure and let us know. So thanks for watching. I'll see you all very soon.